Hello students, welcome to the next lecture on the PY questions. Today we will discuss about uniform convergence. We will cover all those questions from the GATE 1997 to 2023. Myself Dr. Harish Garg. You can simply follow my YouTube channel Dr. Harish Garg and scan and join my WhatsApp group if you want to discuss some more thing. So what is the objective of this lecture? We will try to cover all those questions related to the uniform convergence and uniform continuous from the year 1997 to 2023. We will cover the 35 plus questions in this lecture and all are with the help of the simplest approach. You can see at my YouTube channel there is a playlist of the CSR UGC NET, GATE and IIT JAM. You can simply follow it, and where you can find the PY questions of the previous year GATE as well as the CSR NET examinations of the each topics of here. So let's start with this video. So remember, this is a unique approach which is only available at my channel. Now we will describe about the uniform convergence. There is always a two kind of the questions. One is you have to check about the uniform convergence of the sequence. Second is you have to check about the uniform convergence of the series. How you can proceed whether if you have a sequence or if you have a series, how you can check about the uniform convergence. I will tell you a very simple unique approach. Whatever the f of n is given to you, you can firstly find the limit and check whether there is a existence, and if it is existence, check whether it's a continuous or not. If it is not continuous, then it is not a piecewise convergent. Once it's not a piecewise convergent, then you can simply say it is not uniform convergent. So whether it's a sequence or the series, you can simply check like here. On the other hand, how you can proceed for the sequence, how you can proceed for a series. Whenever there is a sequence is given to you, you always apply the MN test. What is the meaning of that? You firstly find the value of the fx, which is nothing but my limit of this fn. Fine. So as n approaches 0, you can find this, and based on this you can find that Mn like of this, that is the supremum of all those domain of the x. If it goes to the 0 as n approaches infinity, then you can say this sequence is my uniform convergent, otherwise not. Remember, it must be the 0. If it goes to say 1/2, which is not be 0, so it is not uniform convergent. Second way, how you can check for the series. Whenever you have a series, you can always start with the absolute value and you try to prove it is a less than of something. Then check whether this h of x, series h of x, is convergent or not. How you can check for the convergent? You can check about by using the p test. You can check either about the root test. You may check about the ratio test, or any of the testing are there. So you can use any of the tests and check if this is a convergent, then this is my uniform convergent, otherwise not. Otherwise, there is one more method you can check. You can find the nth partial sum sequence of this series. So what is the meaning of the Sn? This is nothing but f1 plus f2 up to fn. You can write this series and then check about the limit of this Sn. If this limit exists and continues, then you can say this series is convergent uniformly, otherwise not. Also remember that the uniform convergent implies the series is or sequence is also there continuous or convergent. So if series is uniform convergent, it means it is a convergent. Second way, how you can check about the uniform continuous. How the target is how you can check the function is a uniform continuous. Remember, not a convergent, it's a continuous. So I will tell you 3 rules. First rule is you can check if the closed interval is given to you. You just only check whether the function is continuous on the closed interval or not. If it is a continuous in the closed interval, then it's a uniform continuous. That's a very simple rule. If it is defined on the open interval, then only you can say this is the uniform continuous. Make sure the f is a continuous and the right hand side limit of the a and the left hand side of the limit both exist. Both may or may not be the same, but both existence must be there. Third rule is if you prove that f is your differentiable function such that it is a bounded. What is the meaning of that? It means f dash is my bounded or ellipse is continuous. Then you can say f is my uniform continuous. So based on these concept of the uniform convergence and continuous, we can solve this PY questions with a very simple manner. Look at the first question. So look at that. Your target is to find the series. You have to check about the series. So what is the rule is, you have to start with this absolute value and write this here. I can firstly think about this n, g. So what is the g of n? You can clearly say this is less than of 1 by n square. Why? Because 1 over 1 plus x square is always less than 1 when x lies between 0 and 1. So clearly say this series is convergent by p test. Fine. So once this is a convergent, it means g is my uniform convergent. So it converges uniformly but not g. So A option is cancelled, D option is cancelled. Now check about this. So look at that. You are unable to write this is less than of something. Fine. So what you can do, you can write the nth partial sum sequence. So f1, f2 and so on, fn. So I can write x square is my constant because it is independent of n. If I substitute n is 1, it is a 1. If I substitute n is 2, it is my 1 plus 1 minus x square of 2 and so on. So do you remember which series is here? Which series? This is a geometric series. What is the sum of the geometric series of the nth term? 1 minus x square over n over 1 minus r. Fine. Now clearly says this x square will be cancelled out. So your expression will be here. Now you can find the limit as n approaches infinity. So what is that? You can see when x is 0, answer is 1, and when x is 1, then again its answer is 1. But if x is lies between 0 and 1, so clearly say the answer will be 0. So what is the meaning of that? Limit does not exist. So if limit does not exist, it means it is not piecewise, not uniform continuous. It means G is a continuous but not F is the right answer, and this option is cancelled out. So the correct answer is my B is my correct option. So remember, always you have to check about whether you are talking about the series or the sequence. Now let's start with this quickly. Again, you are talking about the series. So you start with this value, absolute value of this. So what is that? This is nothing but it is always be less than of here. Now you all knows the series, this is convergent by p test. So what is the meaning of that? This is my uniform convergent for all x. So it is a correct option. It's a pointwise but not uniform, cancel out. Its convergence to the L1 but not converges uniformly, cancel out. Does not converge this point. If it is a uniform convergent, is always implies it is a piecewise continuous. But the converse may or may not be true. So that's why the answer is my A is my correct option. Now again you can see they are talking about the series, and you have to check which of the following statement hold. A very simple approach I can tell you. There is no need to solve. Remember, you can solve this question with the help of the radius of convergence. Fine. You can start with this question like of absolute value of this and check whether it's a convergent or not. But I will tell you again another simplest way. Look at the intervals. You can check about x is equal to minus 1 firstly. What is my series? Minus 1 raised to power n. This is my alternating series. So you have to apply the Leibniz test. What is the an? An is 1, which is not goes to the 0 as n approaches. What is the meaning of that? It is not convergent. If it is not convergent, it means it is not uniform convergent. So the first option cancel out. Similarly, at x is equal to minus 1, it is not convergent. Again, x is equal to minus 1 is there, so it is not uniformly convergent. At x is equal to minus 1, what is the series is? Minus 1 raised to power n over n. So what is that? Again, this is the alternating series. So you can see this is my Leibniz test and it is a convergent. Can you check about the x is equal to 1? So when x is equal to 1, the series will be my here. So clearly say this is my divergent by using the p test. So it means this option is also cancelled out. Look at the last option. When x is equal to minus 1, it will be here, which is a convergent by using the Leibniz test. When x is equal to 1, again it is a convergent by using the p test. It means this series convergent uniformly over this closed interval. So the right answer is my D is my correct option. Fine. Otherwise, this is the first method. You may apply the second method as well, like the radius of convergence, or I can firstly take about this second method, like of this series, because this is a series. So you can start with the absolute value of this. What is that? X. From here you can see x is less than equal to 1. So which is my 1. So what is that? It's a constant series. Fine. So always remember the constant series, say alpha is my constant, this is divergent always, provided alpha is non-zero. And when alpha is 0, that means your series will be 0, 0, 0. It is always convergent. For example, if you write as a 2, that means 2 plus 2 plus 2 and so on. It is a divergent series. But you can see this is a 1, so series 1 is my divergent. So once it's a divergent, it means it is not uniform convergence. Again the first option cancel. Again by using this, again it's a cancel. Look at this third option. You can start from here, which is x, the maximum value of the x is 1, it is 1 over n. Again you can see this is a divergent by using the p test. Again this option is cancelled. Look at the last option. If you start from here, which is less than equal to 1 by n square, and it is a convergent by using the p test. So this is my convergent, this is my divergent. So this is a convergent, so this is my right answer. So either you can substitute the endpoints, or you can apply this as I told you away. Also you can find the radius of convergence and check about the boundary points. Okay, look at this another question. Again the interval is given to you. So best way is that we can check about the interval. So firstly we can say the closed interval. So say x is 1. This series becomes my 1 by root n. Clearly says that this is my divergent. Why? Because n is my half is my less than or equal to 1. So it means at x equal to 1, this first series is my divergent. So both series converges wrong, both plus 1. So this is a plus 1 exactly, maybe, and here. Now we can check about x is equal to 1 for the second series. What is the x is equal to plus 1 is? It's a 1 over 1. Again it's a divergent. So it means both the series divergent, but we are talking about the convergent. Now look about the x is equal to minus 1. What is my first series is? It's a minus 1 raised to power n over root n. It is a convergent series by using the Leibniz test. Fine. Look at the second series. It is minus 1 raised to power n. Again it is a convergent series by the Leibniz test. It means both the series convergent at x is equal to minus 1. So you can see this is a open interval minus 1. It's exactly 1. Wrong. Both convergent on the closed interval minus 1. Fine. Both convergent on the x equal to plus 1. That's a wrong. None of them convergent on this. Is it true? None of them is convergent on this. Again it's a cancel out. Sorry, look at that. Third option. Exactly one of them convergent on the open interval of this. So can you say which one is the, how you can say which one is the correct? Both convergent, sorry, this is the both convergent, sorry, this is there. Both convergent on the closed interval. Both convergent on the closed interval minus 1, that's correct. And open interval of 1. So you can see both are not convergent. So this is the correct option. Exactly one of them convergent on the closed interval 1. So you can see exactly one, but none of them is a convergent. So this option is cancelled. Right option is only B is my right answer. Now you can see this is my sequence. They are not talking about the series. While this is my series, this is my series, this is my series, and this is also my series. So now once is a sequence, you have to apply the MN test. Fine. Again a very simple. Let's start with the Fn. Firstly find the limit as n approaches infinity of Fn. Fine. So what will happen? So what is the closed interval is 0, 1. So if x is 0, what is the answer is 0. If x is equal to 1, what is the answer is 1 over 2. You can see limit exists but not continuous. Fine. Limit exists but not continuous. Why? What is the answer of this when x is lies between 0 and 1? So this is the 1 over n is a 0. So clearly says that at x is equal to 1 is not a continuous. From here it's a 0, it's 1 is there. So if it is not continuous, it means it is not piecewise. If it is not piecewise, this implies it is not uniform convergent. Fine. So first one is not uniform convergent. Look at the second one. You can find the limit of the g as n approaches infinity of gn. So when x is equal to 0, answer is 0. Fine. When x is equal to 1, then it is a 1. It's a 1 over 1 plus n. So as n approaches infinity, again a 0. When x is lies between 0 and 1, that means you take x is 1 over n. So this value will be 1 over n raised to power n, 1 plus, when x is equal to 1, it's a 1. So clearly says this will goes to the 0. So what is the meaning of that? It's a continuous function. It's a piecewise continuous. Then we can check about this Mn test. You have to check about the supremum of all those x. Gn, what is that? Gn is x raised to power n, 1 plus nx minus of the g. G is my 0. Now how you can find the supremum over the closed interval 0, 1? You can simply take denominator as a 0. X will be 1 by n, irrespective of the plus minus sign. So you can substitute here, this is over 2. It goes to the 0 as n approaches infinity. So what is the meaning of that? Mn goes to the 0, it means this is my uniform convergent. So yes, Gn is a uniform convergent, both none. Fn convergent uniformly cancel, Gn convergent, but F is not, is the right answer of this problem. Again, you can see they are talking about the sequence. So you firstly find the value of the limit of this. Fine. So this is my f. So what is the answer is? So x is my closed interval. So if I take x is my 0, it's a 0 over, so it's a 0. When x is 1, it is my 2 over 1 plus 1 minus 2n of whole square. So it's my 0 again. And when x is lies between 0 and 1, so you can take x is my 1 over n, substitute here, the numerator will be this one, denominator will be here, and plus when x is equal to 1 by n, so it will be my minus 1, is a plus 1. So what will happen as n approaches infinity? Again it goes to the 0. So what is the meaning of that? It is my piecewise continuous. Fine. So you can see the third option is cancelled. Then you can check about this here, supremum of function 2x square divided by x square plus 1 minus 2nx minus of 0 over the domain of 0, 1. So if I take the denominator as a 0, so we will get x is 1 over 2n. Substitute all this value here. The numerator part will be 1 over 4n square, 1 over 4n square plus 0. Clearly says it goes to the, what is that? It goes to the 2. It goes to the 2. It is not 0. Fine. So once it means it is not uniform convergent. So converges uniformly? No. Does not converge uniformly? Correct. But it has a subsequence that converges? No, because it is not a uniform convergent. It means it does not have any subsequence which converges uniformly. Fine, because it is not a subsequence. So convergent point wise correct option, but not have a subsequence that converges to, this is the right answer. Again you are talking about the sequence. So first you can find the value of the g as n approaches infinity. So firstly, because it's a complete R, so if I take x is my 0, answer is 0. If I consider x is my non-zero, fine, so it's a constant number, so it's a 1 over is 0. So it means this is my piecewise continuous. Fine. Then you can define, say m is there, it's a supremum over all those x such that g is my x over 1 plus nx square minus 0. Fine. Then how you can check whether it's a uniform convergent or not? You can take x is my 1 by root n, because if I take the denominator as a 0, you can easily find the value of the x as 1 by root n. If I substitute this value here, the numerator will be this, denominator will be 2. So again it shows that it goes to the 0. So therefore the sequence Gn is my uniform convergent. So G does not converge uniformly, cancel out. Now all these rest options are talking about the derivative. So can you find the g dash of x? So can you find the derivative of this? So what is the derivative is 1 over 1 plus nx square minus 2nx square divided by 1 plus nx square of here. So if I take the LCM, 1 plus nx square, fine. So the numerator part will be 1 minus nx square. Now again you have to check whether it's a convergent or not. You have to check the limit. If x is equal to 0, answer is 1. If x is my non-zero, the answer will be 0, because you can divide it by n square, and you can see here. So clearly say that it is not piecewise continuous. So if it is not piecewise continuous, it means it is not uniform convergent. So g dash is a piecewise continuous. Cancel out. G dash and converges uniformly on all the closed intervals that does not contain 1. Okay, so this is, what is the point of discontinuity? Discontinuity is my x is equal to 0. It means this function is not discontinuity at x is equal to 0. So it's a convergent uniformly on any which does not contain 1 cross, because it does not contain 1 means it belongs to the 0, but he said it does not contain 0. That is my right answer, because this function is not a piecewise continuous at x is equal to 0, while rest of them is a simply prove that. So the right answer is my D is my simply correct answer. Once you can see this is not a piecewise continuous at x is 0, you can simply define g dash minus of g. It will be same here. You can again take 1 by root n. If you substitute, it will goes to this 0 as here. So it is a piecewise, it is a uniform convergent, but it does not contain the 0. Now again you can see this is a GATE 2004. Again they are talking about this. They are talking about only uniform convergent, not about the here. This is the convergent. It's a continuous. So what is the tips? As I mentioned you, if f is continuous on the closed interval AB, then it is a UC, uniform continuous. If f is continuous on the closed interval AB, then you have to check about the limit of f at 0, a positive, and limit of the f at b negative. Both must exist. Fine. Then you can say it's a UC. Now look at that. They are talking about the continuous, continuous, and continuous. Look at the intervals are my open interval. So we have to this one. So firstly, I can write this expression as what are the pairs of this? It's a 0, 0, it's a 0, 1, it's a 1, 0, it's a 1, 1. Now I can check at this point firstly. What is the limit of f at this point? What is the limit of g at this point? So what is that? When x approaches 0 and 0, the answer will be 1 over 1. It's a existence. What is the limit of the g at 0, 0? It's a 1. 1 minus 1 is a 0. So it's a 1. Again 1. So both existence. It means this is my uniform continuous. At x is equal to 0, 1. X is equal to 0. So answer will be 1. This is the answer of the f. This is the answer of the g. At x is equal to 1. Y is equal to 1 and x 0. It's again a 1. Both are existence. Fine. It's also the UC. Check about the 1, 0. When it's a 1, it's a 1 and it's a 1. So it's a half. It's a 1 and it's a 0. So it's a minus 1. So it's a 1 over 0. It is not exist. Does it existence? Not exist. Fine. It means G does not existence. So G is not uniformly continuous. So this option is cancelled. This option is cancelled. Now look at the f at 1, 1. At 1, 1 the limit is my 1, and this is there is no need to check. So in f is always be a continuous. So f is continuous but g is not. F is continuous, g is not is the right answer of this problem, because this is my open interval. So you have to check only about these limits. Okay, now they are again the convergent. Again they are talking about the sequence. So firstly we can find the value of the f. So what will happen on the domain is a complete R. So if x is 0, answer will be my 0. If x is my non-zero, so what will happen? If x is non-zero, then can you let me what is the answer of this? If x is non-zero, then what is the limit as n approaches infinity? So because of this n, it's a 1 over infinity 0. So what is the meaning of that? Fn is my piecewise continuous. Fine. Then we can define the value of the m as supremum of complete x of 2x square divided by 3x square plus 4 minus 5nx. Then take the absolute value minus of 0. Now take the denominator as a 0. I can simply take this value as a 0. Then x will be my 4 over 5n. So if I substitute here, what will happen? X is my 16 over 25n square divided by 3 into 16, 25n square plus 4. This will be 0. So clearly say that n square will be cancelled out, which is not goes to the 0, because you can see n square will be cancelled out and its part is my constant. It goes to the 2 over 3, which is not here. So what is the meaning of that? It is not uniform convergent, but it is a piecewise continuous. So this is my correct statement, this is my false statement. So only P is my correct statement, is the right answer. Okay, look at this one. So they are again talking about the uniform convergent over the mid-tweak. So how you can think about that? Look at that. This is not talking about the convergent. They are talking about the uniform convergent. Fine. Okay, D1 and D2 are there. So how you can think about that? So firstly, we can check about the D1. Fine. So how you can think about the D1? That's again a very simple. You can start with this. What is the fx? This is the x. This is the fn is x into 1 plus here. So clearly says if you take the limit of the fn, it is my f, because it's x. It means fn converges to the f piecewise. Fine. Then you can define the matrix over here, which is convergent uniformly. So we can start with the D1, fnx, comma fx. Fine. So if I substitute here y minus z, so that means fn minus f. What is the value of the fn is x plus x over n minus here. So what is the answer is x over n. So what is the upper bound of the x is? It's a greater than 0. So clearly says that this is not goes to the 0. Why? Because its x is not a bounded. So if my domain is my say 0 comma 1, then clearly says this part will be less than of 1 by n, then it goes to the 0. But here the domain is x is greater than or equal to 0, so this part will not goes to the 0. It means on the D1, fn is not converges to the f uniformly. Fine. So it means this is my false statement. Check about the D2. So for the D2, again fn is my here. We can start with this D2 of fn comma f. So if I substitute here, what is the fn is? Fn is my x plus x over n, and this is my x. So if I substitute it, this is my y, this is my z. So this is, I can return this number as here, divided by 1 plus mod x, 1 plus 1 over n, minus x over 1 plus mod x. Fine. This is there. Now if you simply take the LCM, the numerator part will be here. You can see it's a x plus x. X will be cancelled out. Then it is x over n plus x mod x over n. Fine. These are the two terms, plus x mod. And similarly, if you bracket them, okay, I can write the first term complete, minus x mod x of 1 plus 1 by n. So clearly says 1 will be cancelled out. X mod x, if you open them, that will be cancelled out. This part is also cancelled out. So the only part will be x by n over this part. So clearly says which goes to the 0 as n approaches infinity, because the numerator part goes to the 0. So it means this is my uniform convergence. So this has a matrix, only the D2 is my uniform convergence. Now look at this one. Again they are talking about the series. Fine. Whether it f1 is a continuous and here. So we can start with the mod of f1. We can see it is a less than, because sin x is always be less than of this. What is the domain of x is 0 comma 1. So I can also written as of this. So this is my convergent by P test. Fine. So therefore F1 is my uniform, series of the F1 is my uniform convergent. Look at the F2. So if we start with the mode, it is not possible. You can write is less than of something. So I can write as a nth partial sum sequence, F1, F2 up to Fn. So what is the F1? This is my Fn. Fine. So if I substitute 1, so the only term will be x square. So I can take x square as a common. So it will be 1 minus x square, then 1 minus x square of square, and so on. The last part will be x square of n minus 1. So you can see that this is my GP series. So A 1 minus r divided by 1 minus r. So you can clearly say it's x square, it's a cancel out. So expression becomes my 1 minus x square of n. Now you have to check whether the limit of this Sn existence and continuous. Fine. So clearly says when x is my 0 and x is my 1, the answer will be my 1. But when x is lies between 0 and 1, this part becomes my 1, so it will be my 0. So clearly says that it is not continuous. Once it is a not continuous, it means it is my not uniform continuous. So F2 is my not continuous. It is not, but this is my yes. So F1 is continuous, but F2 is not. F2 is continuous, cancel, both cancel, both cancel. So the right answer is my A is my correct option of this example. Okay, look at this one. On the closed interval, this again you are talking about the series. So we can start with this absolute value. But this is the alternating series. Fine. This is the alternating series. If I open this bracket like of here, this is x square over n cube plus summation of minus 1 raised to power n minus 1 over n. So clearly says that this is my convergent. Fine. It is convergent. This is also convergent. Why? Because it's a how you can say it's a convergent. Again, it's alternating series, but it's a power series. So you can take the absolute value. It is nothing but my here. So x cube, x square will be less than equal to 1 over n cube, and it is a convergent by the P test. So this is a convergent, this is a convergent. So this means this series is my uniform convergent. And once it's a uniform convergent, this implies this is my absolute convergent. So absolute convergent correct, and uniform convergent is the correct answer. So because this is alternating series, so you have to think about here. However, how you can think another way? Is there any another method? This is alternating series, so there is no need to start with the modular sign because this is alternating series, so you have to think about the power series here. So the right answer is my A. Okay, the largest interval on which here. So there are several methods. Whenever there is a question of the largest interval, fine, this is the interval, you always check about the radius of convergence. Fine. Fine, you can see x minus center is my 0 is less than or equal to r. But I will tell you the simplest way. You can check about the options. Look at the closed interval firstly. As I mentioned again, what is the series? This series at x equal to minus 1, it is my minus 1 raised to power n minus 1 over n. So what is that? This is nothing but my 1 over n. Is it a convergent? This is a divergent by using the P test. So what we are talking about, it means all those options which consist of the minus 1 is a divergent. So B option cancel, D option cancel. Now look at this. I think this one of the option is my closed interval. So say this is my closed interval. Otherwise the A and C options are same. So this is, now you can check about the x is equal to 1. So what will happen at x is equal to 1? The series 1 will be here, and you can see this is my convergent by using Leibniz test. So it means at x and this open interval, it means it is not convergent at open interval. So this option is also cancelled. Right option is my A is the correct answer. And you can see this is the GATE 1998. There is no need to find the radius of convergent. Fine, you can simply start with this, check about the options, and you can get the answer in a very simple manner. Okay, look at this another one. Again, they are talking about the sequence, not about the series. Define the sequence. An plus 1 is an plus half x square minus an square of this. Then on this closed interval the sequence will converge uniformly. So let an converges uniformly on the L. So what will happen? You can take the limit as n approaches infinity each side. So it is L plus L, it's x square minus L square. So what will happen? L will be cancelled out. It's x square minus L square. So what is the right answer? L is mod of x. So the limit will converges to the mod of x. That's simple. That's a very simple target about it. Okay, next one is, it's z is there, which again a series. Fine. So what is the target is? Either you can write the nth partial sum sequence, or you can start with this absolute value of this. So if I start with here z raised to power n of n plus 1, what is that? Mod of z is less than 1, so I can return this number as n of n plus 1. I can again return this number as less than of 3 by 2, which is a convergent by using the P test. So what is the meaning of that? This function is my uniform convergent. So once it's a uniform convergent, it means this is also be a absolute convergent. So where is the answer is uniform convergent and absolute convergent, both are the correct answers. So remember, once it's a uniform convergent, it implies the absolute convergent as well. So right answer is my simple B. You can see how many seconds you need to solve this uniform convergence questions. I hope you can put a like on this my video. Okay, you can share with your friend as well, so that they can also learn in a very simple manner. Okay, next one is GATE 2005. F is a function which is defined like here, and series. Again they are talking about the series. So we can start with this one. Fine. So what is the value of the Fn? Fn is given to be here. Fine. Then what is the value of the Fx? What is the value of the Fx is? Mod of Fx is less than or equal to 1 over 1 plus 2x square. So x is my x plus n whole square. Fine. Now clearly say that this is x square, so I can return this is less than of the n square, because x is my real number. So x plus n is here. So clearly says that this is my, okay, you can write as a equality also. You can see this series is a convergent by using the P test. So it means this series convergent uniformly. This series is convergent uniformly for all x. So what is the meaning of that? It means the first option is it not on this. It's a wrong option. This is not, because 0, 1 is a subset of the x, but it is true for all x. So second option is also cancelled. It is, if it is convergent for here, it is also convergent for this. It is also convergent for this. So C option is the correct option. Neither of is the wrong option. So C is my correct answer. So you can see convergent uniformly. You have to start with the, as I told you, the simplest tool. Whenever there is a series, start with the absolute value or nth term sequence. If it is a series, apply the mn. Kindly put a like on this video if you really feel it's a good one. Now you can see this is my sequence. Fine. So firstly check which one of the convergent or not. Check firstly the limit. We will check about the pointwise convergent. Fine. So what is my Fn is? Firstly xn. So what is that limit? What is the limit is? So clearly says if I take x is my 0, answer will be 0. If x is my 1, answer will be 1. If I take x is lies between 0 and 1, it is my 1 over n. Fine. So this will goes to the 0. Is it a convergent? What is that? If x is equal to 1 as n approaches infinity, so it is not a piecewise continuous. No, sorry, it's a piecewise. When x is equal to 1, it's a 1 over it's a 1 raised to power infinity. It still goes to a 0 if you take as a logarithm term. So what is the meaning of that? It is a piecewise continuous. Anyhow, if it is not a piecewise continuous, then it is not a uniform convergent. But right now it's a piecewise continuous. Then we can define the value of the m, supremum of all those x over the open interval 0, 1 of the xn. So can you find the supremum of this? So clearly says that supremum is 1. Okay, this is a supremum. So the supremum is existence at 1, but you can see this is not goes to the 0. It means it is not uniform convergent. So this is my not uniform. So A option is cancelled, C option is cancelled. Now look about the G. So we can firstly find the limit as n approaches infinity of the Gn. So clearly says over the closed interval, if x is 0, answer is 0. If x is 1, answer is again 0. If x lies between 0 and 1, answer is again 0. So this is a piecewise continuous. Then we can define the n, supremum of all those x closed into open interval 0, 1 of xn and here. So what is the supremum of this? How you can find the supremum? I can simply take y is my here, then I can find the maximum value this. So what is the derivative of this? N xn minus 1 of 1 minus x and minus of xn is 0. Xn will be cancelled out. So n over x is 1 minus x minus 1 is 0. So you can see n minus nx is equal to x. So x is my n over n plus 1. Fine. So I can check the value of the m at this point. So this is x is my n. So it is n over n plus 1 raised to power n, and it is 1 minus n over n plus 1. So clearly say that what is the limit of this? I can return this number as of this, and this number is my 1 over n plus 1. This part will goes to my e, this part will goes to my 0 as n approaches infinity. So it means this value will goes to my 0. So therefore it is my uniform convergent. So this is my uniform convergent, but Fn is not. So neither of them is a cancel out. Gn is a uniform convergent, but Fn is not, is my correct answer. Okay, again they are talking about the sequence. Fine. So you can start with the Fn firstly. So Fn is xn, which is similar to this. You can see that this is not a uniform convergent. So it means Fn is not uniform convergent. So Fn is not convergent. Fn is a convergent, cancel out, both are here. Now check about the Gn. So check about the limit as n approaches infinity of cos x minus n of pi by 2. So you can see whenever x is my n minus 1, so when x is my n minus 1, so this value will be my minus pi by 2. Cos pi by 2 will be, when x is my n minus 1, cos pi by 2 will be my 0. When x is my n plus 1, what will happen? It's n plus 1 is a pi by 2 is a 0. So both the endpoints, the value give a 0, so it is my continuous. And if x lies between them also, if x lies between them, then again it's a 0. Endpoints are 0 here, so it means this is my piecewise continuous. Then you can define the m, supremum of all those x such that cos of x minus n times pi by 2. Fine. Now you can check what is the max value of this over this domain. Domain is my 0, 1. Fine. So I can simply take y is my cos of x minus n pi by 2. I can simply take y dash is 0. So it will be the sine of this. When sine will be 0, when this value will be my n pi. Fine. So this will be here or 0. So you can simply say this value will be my 2n. So x will be my 2n plus n. Fine. If I substitute here, so it will be my cos of pi. No. Is it true? This value will be my 0. So sine 0, y dash will be my sine of x minus n pi by 2. This will be 0 when this part will be my n pi. So this will be cancelled out, 2n plus 1. If I substitute here, this will be my 2n pi by 2. So what is the value of this? It's a minus 1. So it is not goes to the 0. We have to check also at the closed interval because it's a closed interval. So when x is equal to 0, it's a cos n pi by 2. When x is equal to 1, it will be n pi 1 minus n pi by 2. Yes, it is there. You can see because the function is defined only on the n minus 1 and n plus 1. Fine. So what will happen if you consider as the n minus 1? When it n minus 1, the answer will goes to the pi by 2, 0. N plus 1, again it goes to the 0. So both the cases it goes to the 0, because this value is not lies in this case. So therefore you have to check only at the endpoint. Endpoints are here, which goes to the 0. It means this is my uniform convergent. So this is my uniform convergent. F is not, but G is, that's the right answer. A option is cancelled. Remember that the critical point, this point is not belongs to the n-1 and n+1, because this is the n plus something which is lies outside of here. Okay, next one is which of the sequence converges uniformly. Again, what you can think about that? You can check about the F for the first case. What will happen as n approaches infinity of this? So you can see, if x is my 0, fine. If x is 0, it is value 1 over n is 0. If x is equal to 1, then it's again a constant, again a 0. If x is lies between 0 and 1, but due to the 1 over n is again a 0. It means this is my piecewise continuous, which is not a uniform convergent. So what we can do, we will try to find which is not a piecewise continuous firstly. Fine. Those sequence which is not a piecewise continuous implies not uniform convergent. Look about this one. If I take this, x is my 0, the answer will be 1. If I take x is 1, answer will be a 0. Fine. Clearly says that it is not a, it's a 1 over n. If I take x is lies between 0 and 1, so it is 1 over n of this. Clearly says that it is 1 over e, which is not goes to the 0. It means this is not piecewise. It is not a piecewise, it means this is not a uniform convergent. Moreover, if you are thinking about there is something mistake or you can some confusion, you can define the nth partial subsequence f1 of fn. So what is the f1? 1 minus x. This is 1 minus x square, and so on, 1 minus x of n. This is a GP series. This is my A into 1 minus r, fine, over 1 minus r. So clearly say that this is the x, 1 minus x over x, and 1 minus of this. So what will happen? If x is equal to 0, this value will be 1 minus 1. Okay, so it's a 1. If x is equal to 1, it will be 0. So clearly says it is not a, limit does not exist. Again, it is not there. You can check about this one. You can see you have to check about the uniform convergent. So this value over n. So what will happen if you take limit n approaches infinity? So clearly says that it's infinity over infinity. So it's a x which is a finite here. So which is a uniform, is a piecewise, it's a less than over 1 here. So the right option is only my, this B option is there, which is not convergent uniformly over this domain. So the right answer is my B is my simply correct answer. Also you may check about the another one, because they are the sequence. You can define the piecewise continuous firstly, and then you can check about the Mn here. You can simply, because there is only the one correct option is there, you can simply, this is not a piecewise, so that's why you can simply see it is not a uniform convergent. Okay, look at this another one. Which of the following is a uniform continuous? Now they are talking about the continuous. Fine. So what is that? If f is defined on the closed interval, you have to check only it's a continuous. Fine. If f is defined on the open interval, you have to check about the limit of this f at a positive and limit of this f as b negative, both existence. Fine. Now very simple, the function f is given to you as cos of t and sin of t. So the domain is in the R2. Fine. That is so can I write this function as of this? Fine. Similarly, g is again my here. Fine. These are the elements of this. Now g is my closed interval. So you have to check only this g is my continuous function. So clearly says that it's a continuous function, because the value of the g at this, value of the g at this both exist, and exponential function is a continuous function. So it means G is my uniform continuous. The only rule is you have to check whether if the closed interval function should be a continuous, and G is my continuous. So this is my uniform continuous. Look about this, because this is the semi-open. So you have to check the limit of x approaches 2 pi negative of f. Fine. What is the limit of this? Can you calculate the limit of this? So what is the limit of this? It's a cos of 2 pi and 2 pi minus of h, fine, and sine of 2 pi minus of h as limit h approaches 0. So what is that? Cos of 2 pi. What is the cos of 2 pi is plus 1, sine of 2 pi is my 0. Fine. But what is the value at x is equal to 2 pi? Because the 2 pi is not being given in this interval. Fine. So clearly says, you can see the limit x approaches 2 pi negative of the f is not equal to the limit of x approaches 2 pi positive, or you can say which is not equal to the f of 2 pi, because this 2 pi is not in the domain. So once is not in the domain, you can see this function is not in my uniform continuous. So this f is not uniform continuous. This is cancelled, this is cancelled, this is cancelled. Right option is my B is my. Simply you can write the answer as here. Okay, look at this another one. A function is given to you. They are talking about the continuous, uniform continuous, ellipsis continuous. Okay, very simple. What is the meaning of the ellipsis continuous? You have to check about the derivative. It must be finite. Fine. Okay, so whether the function is continuous or not, you can firstly find the derivative. What is the f dash is? It's a 2 sine raised to power 4x cos square x. Fine. What is the f dash? So it's a sine and cosine. Definitely it will be less than of, this value will be less than of the one, it will be here, that's a less than of finite. What is the meaning of that? A function f dash is my finite. What is the meaning of that? That means f is my uniform convergent, f is my bounded, fine, f is my ellipsis continuous. Now f is not continuous, cancel. It is not uniform continuous, again cancel, because f is a uniform continuous, f is a bounded, f is a ellipsis continuous. It's a uniform continuous but not ellipsis continuous. That's again a cancel out. It's only the D option is my right answer. Okay, look at this one. If which of the following statements are true? There is more than one. What is the L1? You all know what is the L. You know what is the LP norm? So that is whatever the function is given to you raised to power p summation of 1 over p, and if it is a continuous, then instead of that you can simply take as a integration sign. Fine. Now what is that? If p is equal to 1, so it means you have to simply integrate of this. Fine. Now look at that. If f is okay, so firstly I can tell you the tips. What is the shortcut tips for you? Remember this rule. If f is my L1R, fine. What is the meaning of that? You simply remember this. It means the limit of this function as x approaches infinity either exist or not. It may or may not exist, but if it exists, then it is always 0. If it exists, then it is always 0. If it does not exist, that's a fine. So if this is there, then it's a continuous. Fine. Okay, which of the following statement is true? If f is there, then f is a continuous. This is not true because the limit may not be exist. So this option is cancelled out. So if p is cancelled out, this option cancel, this option cancel. So we can simply check about the s, okay, or q and r. Okay, if f is my L1 and limit exists, then the limit is 0. This is my correct statement. If f is there, then it is a bounded. It is not true. Why? Because first option is not true, because if limit is not continuous, it is not a bounded. So this is, if f is uniformly continuous, then the limit exists and is equal to 0. The same thing for here. So q and s both are my correct statements. So which is that? A is my correct option. That's a very simple one line shortcut tips for you. Okay, look at this another one. Which of the following is the Riemann integrable function? This is already given to you. That means a piecewise continuous is already given to you. It is already a Riemann integrable. So what is the rule for that? You all know, if it is a piecewise continuous, then this converges uniformly if f is my Riemann integrable function. Fine. So it means this is my correct statement. Fine. F converge. Okay, we consider the following statement. Which of the following is not true? P1 implies P3. P1 implies P3. That's a correct statement. Why? Because if Fn converges uniformly, what is the meaning of that? This is there, and F has some Riemann integrable. So this implies is a correct statement. But we need a not. So this is my correct statement. P2 implies P1. That's again same, because if derivative is my uniform convergent, so the previous one, that f is also the uniform convergent. This is also my correct statement. P2 implies P4. If f dash is a uniform continuous, so what is that? It is a bounded as well. If it is a bounded, it means f is my differentiable. So it means this is also the correct statement. So it means this the only left option is the right answer. What is that? P3 implies P1. That means this implies this one. That is not true. This is a standard result, because this is only true when f is a uniform convergent. If f is a uniform convergent, then you can say the limit converges to the integration, but the converse is not true. That you already studied in your master class. There are so many examples are there. So for example, there are so many. Can you provide the one example? A very simple is n square x over any are there, n x power 4, or I can take simply this one, or I can simply x or x square. I can take square of this. Okay, I can simply take and I can simply square of this. Clearly says that this is not a uniform convergence. So this is my correct answer of this problem, because they need a false state. Okay, look at this one. F is defined over here. T is my mapping. Which of the following uniform continuous? Fine. They are not talking about the uniform convergent. They are talking about the continuous. So look at the first case. Firstly, we will think about the T. Fine. So what is your target? Your target is to prove if you take any two elements from the domain, it must be less than of upside. Fine. So I can take any two elements from the T. Say x and y is in the T. What is that? If I simply take x is my natural number and y is my n plus 1 over n. So clearly says that x minus y is less than of epsilon, delta or epsilon, because what is the x is here, which goes to the 0. Then what is my fx minus fy? I can start from here. X is my natural number. This is my natural number. When x is my natural number, answer will be n. Second is n plus is not my natural number. If it is not, the answer will be 0. So clearly say that it is my n, which is not goes to the 0 or not goes to the upside. It means for t, the function is not uniform continuous. Fine. By the definition, it is not continuous. So t is a continuous, cancel out, both is a cancel. Now you can check about the n. So for the n, so what is that? How you can say that? So remember, you have the usual matrix. So you have the usual matrix on the R. So what is the usual matrix on the R on the natural number? You know, this a very simple. It's a discrete matrix. Fine. And we all know on the discrete matrix and on the natural number here, which is given to you, any function is my uniform continuous. On the discrete matrix over the natural number, that is the usual matrix, any function is my uniform continuous. So it means on the f is a uniform continuous, but on the t is not. So n but not t is a correct statement, is not. So the right answer is my A is my correct answer. Okay, look at this another one. A function is given to you and you are talking about the sequence or series. Nothing is given to you. They are talking about the convergent here. Very simple. You have to check which one is a point-wise convergent. So what is the meaning of the point-wise convergent? You have to take the limit as n approaches infinity. Fine. So what is that? If you take n approaches infinity, what is that? This 2 by n is goes to the 0. The first term, what is the meaning of that? 0 less than equal to x less than 0. Is there any term present in this case? No. So it means it will be 0. And this part will be 2 over n is a 0 less than equal to x less than of 1. The answer will be 1. This is the limit. Fine. Now which one is the case? 1 when it lies between 0 and 1, otherwise 0. No, because at x is equal to 0, at x is equal to the answer goes to the 1, but it's 0. It means Fn not convergent uniformly over the 1. Look at this one, it's a correct statement. Because what is the meaning of that? It is complete 1. So it means Fn goes to my G2 piecewise continuous. Fine. Now, so it means Fn converges uniformly. Now you have to check whether it goes to the uniformly or not. Again, very simple. You have to check about the Mn. Supremum over the domain. Domain is my closed interval 0, 1. Fn. So nx minus 1 minus of, or instead of this, firstly I can write here as Fn minus, it converges uniformly over the G2. Fine. Now you can take any value. Say x is my 1 over n. Any number between the 0, 1, because g is my here. So what is that? It is my 1 over n. This is my 1 over n. What is the value of the Fn at 1 over n? 1 over n is lies in the first case. So it is my 1 over n. 1 minus 1 is 0. Minus, what is the G2? 1 over n is 1. So what is that? It is 1 not goes to the 0. It means it is not uniform convergent. So this is cancel out. Fn converges to the G2 pointwise but not uniform. The correct option, right option is my B is the right answer. You can see that very simple, because they are talking about the pointwise. You can simply take the limit as n approaches infinity. This value will be my 0. So the first expression becomes my here. None of the value will satisfy. Less than 0 but greater than equal to 0. So answer will not be here. And so. Okay, look at this one. Which are the following sequence? So they are talking about the sequence. Fine. So you firstly find the limit of this Fn as n approaches infinity. So it goes to the 0. Fine. So which is a continuous? Single point is a piecewise continuous. Now whether it is a uniformly convergent or not, you can define over the supremum Fn 1 over 4n plus 5 minus 0. So clearly says that it goes to the 0 as n approaches infinity. So therefore Fn converges to the F uniform. Fine. Now second part is they are talking about the L1 now. So it means this is fine. So it means pointwise but not uniform cancel, but not pointwise cancel. Now also this sequence convergent L1 or not. So how you can check upon the L1? So basically on the L1 norm, what your target? Your target is to check on this here Fn1 of dx whether it's a finite or not. This is your target and we are targeting to the 0. So basically your target is to prove whether this limit goes to the 0 or not. Fine. So we can start with this one. Fn domain is minus infinity to infinity, is break from 0 to n. Mode of Fn is my 1 over 4n plus 5 of dx. So this value mode is a constant value and is a positive. With respect to x is a constant. So it is n over 4n plus 5, because I can return this number as 4n plus 5 is outside 0 to n of dx. So clearly says that this will goes to the 0 as n approaches infinity. Sorry, it is not goes to the 0. Is it goes to the 0? No. It goes to the 1 by 4. It is not goes to the 0. It means this is not uniform convergent on the L1 norm but uniform convergent on the standard one. So it's not, first is the correct option, B is the wrong answer. So A is my correct answer. Okay, look at this one. Function is given to you, f, this is only g is given to you, Fourier series. Okay, there is no need to solve the problem. What is the shortcut tips for you for the Fourier series? So if you remember that the convergence condition of the Fourier series, that is the Dirichlet condition. What is that? F must be the continuous on the closed interval a comma b. Fine. F must be same, function value must be same at the boundary point, and third one is f dash must be my continuous. If these three conditions satisfied, this implies the Fourier series converges uniformly. Fine. There is no need to find the Fourier series of this. That's a very simple shortcut tip for you. So what is my f? This is my pi square minus x square. Fine. Look at the first part. F is a continuous, is a polynomial, is a continuous satisfied. What is the domain is? Minus pi to plus pi. So you can see f of minus pi and f of plus pi both are same, is to be a 0. Second condition also satisfied. Is a derivative. Derivative is my polynomial. Polynomial is a continuous. So these three properties all satisfied for the f. It means the Fourier series of the f converges uniformly. Yes is my correct statement. Fourier series of the g converges uniformly on the g or not? You can see that. Clearly say this function is not a continuous. Why? G is my discontinuous. At which point? G is my discontinuous at the point x is equal to 0. So what is the meaning of that? The first condition is not satisfied. So once it is here, it means it is my not uniform convergent. So this is my not uniform convergent, while f is my convergence. So P, only P is my correct option. P is true, Q is false is the correct option, rest option is false. So sometimes the student may write the Fourier series of this, there is no need of them. You can simply remember this shortcut trick. Okay, look at this another one. A function is given to you, uniform continuous. Remember they are talking about the continuous, not about this convergent. So we can firstly find how you can remove the integration. I can simply start with the derivative. I can simply start with the derivative. What is the derivative of this? It's a sine square of x square. Fine. Now clearly says what is the absolute value of this? It is always be less than equal to 1 because of this, which is a finite. What is the meaning of that? F dash is my finite. What is meaning of that? F is my ellipsis continuous, or you can say f is my bounded, or you can say f is my uniform continuous. Once it's a uniform continuous, it means this is my continuous as well for all these domain. Fine. So once it's a uniform convergent on the all the domain. So what is the meaning of that? It is 0 to infinity. F is uniform not on the 0 to infinity. Cancel out. 0 to infinity correct option. 0 infinity not neither. Fine. Now you can check about this closed interval 0, 1 or opening. Now you can see about it. How you can see that? You have to just simply check whether the limit existence, limit at x approaches 0 positive and limit x approaches 1 negative f existence or not. But I think there is no need to do because it is continuous for all x. So this is the part of the x, so it must be continuous on this case. So this option is cancelled out. This is my right answer. This must be existence. Why? Because we already proved that it is continuous for all x. So this is the part of the x as well. So it is also be a uniform continuous. So the right answer is my C. Okay, look at this one, GATE 2020. The sequence converges. What is that? Your target is to find this limit. Fine. So that's very simple. You can simply take this, a constant part. Limit is independent of the n. So I can take value of the n as infinity. So it's a tan of 0. That's a 1. Fine. So what is the answer of this? 1 over 2 pi, pi over 2. So what is the answer is 1 over 4. So 0.25 is the right answer. That's very simple. Okay, look at this another one. Which of the following is a equicontinuous, uniform convergent, and here. So firstly we can check about the sequence. Find uniform convergent. Find the limit as n approaches infinity. So what will happen? If x is my 0, answer will be 0. If x will be 1, what is the answer is 1. 1 plus 1 minus n square. So again it's a 0. When x lies between 0 and 1, lies between 0 and 1, so take x is 1 over n. So this value will be 1 over n square divided by 1 over n square plus 0. So which goes to the 1. So what is that? Is it a piecewise continuous? It is not continuous. Why? Because you can see at the 1 is a 0, at 1 is my 1. So it is a not piecewise continuous. If it is a not piecewise continuous, it means it is not uniform continuous. So it means it is not uniform convergent. This option is cancelled. Now remember, what is the equicontinuous? What is the equicontinuous? So remember, this is the simplest tip for you. F is my uniform continuous if and only if f is my equicontinuous plus f is my piecewise continuous, or you can say f is a piecewise continuous. Fine. Now clearly says f is my not uniform continuous. What is the meaning of that? F is my not equicontinuous. Fine. So f is not equicontinuous, correct option. This option is cancelled. Now since f is not a uniform continuous, so it means it does not have any subsequence. It does not have any subsequence which converges uniformly. It does not have any sequence, but the last option said it has a subsequence, converges uniformly. That's not a right answer. So it means this option is also cancelled out. And what is the bounded? Is it a bounded? How you can check it's a bounded? So you have to check whether it's a less than of finite or not. Fine. That is true because we all knows what is the limit of a square plus b square. It is always be less than 1. So you can see this is my a, this is my a. So clearly says that this is my always less than of 1. It means this is a bounded. That's fine because I take the absolute value. It is a uniform bounded, but it does not have a subsequence. So the right answer is only my A is the correct answer. Again, there is a question of the equicontinuous, and there are two questions. One is the sequence, second is the series. Okay. One is the sequence, second is the series. So firstly, for the sequence, limit of this e raised to power minus nx I can written as a denominator. So can you find the limit of this? As n approaches infinity, it's a infinity by infinity form. So if I take the L'Hopital rule, so it is my x cube 1 n e raised to power n, which clearly goes to the 0. So therefore f for all the values of the x, it means f is my piecewise continuous. Fine. Then we will check about whether it's a uniform continuous or not. We can define the value of the m, supremum of n x cube e raised to power minus nx minus 0. Domain is my 0, 10. Fine. Because there is no denominator part, so I can simply take y is my nx cube e raised to power minus nx. Derivative with respect to x. So n is my constant. So it is my 3x square e raised to power minus nx minus n x cube e raised to power minus nx. Put them as a 0. So n will be there, x square will be cancelled out, e raised to power minus x will be cancelled out, this will be here. So x will be my 3 over n. Fine. So I can substitute the value here. What will happen over the supremum? So supremum of n x cube 27 over n cube e raised to power minus 3. So clearly say that it is my square. Fine. It goes to the 0 as n approaches infinity. So what is the meaning of that? This fn is my uniform convergent. Fine. Also you can see it is if it is a uniform convergent, also you can see it's a piecewise continuous. So what is the remark? As I told you, uniform convergent implies equicontinuous, uniform continuous implies equicontinuous plus piecewise continuous. So this is already happened, this is already happened, so it means this is a piecewise, it's a equicontinuous is my correct statement. So P is false, cancel, both P and Q are false, cancel. Now you have to check whether it is series is a piecewise continuous or not, or series is my uniform convergent or not. You can define, start with the modulus value. It is nx cube over e raised to power nx. Fine. Now as I see the value of the x will be my 3 by n, I can substitute here. Moreover, can you see this is my, how you can see it's a convergent? We can apply the ratio test. Fine. So you can see n plus 1 over e raised to power n plus 1 x. X cube will be cancelled out when you take the ratio n e raised to power nx. Fine. I have to take an plus 1 over an. So you can see e raised to power nx will be cancelled out, this, and the remaining part will be e raised to power x. Fine. So as n approaches infinity, this part will be my e raised to power x. Clearly says that this value will be, is it greater than 1 or less than 1? This value over the domain here. So when x is equal to 0, answer will be 1. When x is equal to 1, it will be 1 over 2.718. It's a less than 1. So you can see that this number will be less than 1. It means by using the ratio test, this series is my convergent. Fine. So once this series is convergent, it means this is my uniform convergent. But he said not. So this is my false statement. So only P is my correct statement, is the right answer of this problem. There is one more method that's quickly come in my mind right now. Instead of checking the root test, you can apply the ratio test as well. But you can see Fn is nx cube over e raised to power nx. Fine. Now we have seen the function will give you the maximum value at 3 by n. So I can substitute here. So it will be 27 over n square divided by e raised to power 3, and you can see which is always be less, and the rest of the part is constant, it is 1 by n square, which is a convergent by using the P test. So again it shows that this is my uniform convergent, but he said not, so that's why Q is my false statement. Right answer is only my B. Okay, look at this one. Fn is there. Now they are talking about the sequence. Fine. So it's okay. The endpoints are given to you. Endpoints are already given to you. You can check about here. When x is equal to -1. Fine. When x is equal to -1. So what is that? It is my sine of minus n divided by root of n, and clearly say this is my of this case, which is my divergent. Is it convergent or divergent? Which is my divergent? No, sorry. This is the series. This is for the series, but it is my sequence. I can't do like of less than. So we have to apply the MN test. Fine. Okay. So how you can do that? How you can think about whether it's a uniform convergent or not, which does not converge it uniformly, and here. Okay. So at x is equal to minus of 1. Fine. So firstly we can check about the limit. Limit as n approaches infinity, sine nx over root n. So clearly says that domain is my -1, 2 plus 1. When x is equal to -1, when x is equal to -1, it's a sine n over root n. So clearly says this number will be less than of this. Fine. And of this, what is the limit of this as n approaches infinity? This part goes to the 0, this part goes to the 0. So by using the sandwich theorem, this part will be 0. Similarly, when x is equal to 1, again this part will be 0. When x lies between -1, 2 plus 1, again this part will be 0. So what is the meaning of that? Because this part will goes to my 0. So it means this is my piecewise continuous. Fine. Once it's a piecewise continuous, then you have to check whether it's a convergent uniformly or not. You have to check about the supremum. What is that? This is a sine nx over root x. Fine. This is a modulus value which is always be less than of here. So clearly say that it will goes to 0 as n approaches infinity. It means the function fn is my uniform convergent. But he said it does not. Cancel out. Fn when n is 1, 2 is not uniform convergent is again a cancel out. Derivative. What is the f dash? What is the derivative of with respect to x? It's a n cos nx by root n. So I can say this is my root n cos of nx. Clearly says that it does not goes to the 0. Again, if I apply this tool, it does not goes to the 0. It means it is my not uniform convergent or continuous. So again, he said does not continuous on uniformly. So this is my correct statement. Fine. Now check about this one. How you can do like, so integration fn. Fn is my here with respect to x. So 1 by root n is my outside. So sine of nx. So what is the integration of this? The integration of this will be my minus cos nx over n from 1 to, so the numerator part will be the constant. As n approaches infinity, this part will goes to the 0, but he said does not goes to the 0. This option is also cancelled. Right option is my C is my correct answer of this problem. Okay, look at this another one. Now you have to check about the sequence. Fine. But the Sn is my series. Fine. So it means how you can start with it. Either you can start with the absolute value of this. You can think about whether it's a less than of this. It is very difficult to think about that. So what you can do, I can simply write the nth partial sum sequence. Fine. So before that, I can write this as partial sum sequence. Fine. So how you can do? I can simply take this is 1, it is nx, and this is also a 1. Fine. And then we can see 1, 1 and minus. This is my fn. Then you can define the nth partials, because this is the nth partial, f1, f2 and up to fn. Now you can see what is the f1. When n is 1, it's a 1. It is my 1 over x plus 1. Fine. Plus f2, it will be my 1 over 2 minus 1 is x plus 1, 1 over 2x plus 1, plus so on. The last part will be my here nx plus 1, n minus 1 x plus 1. Now you can see the first term, last term cancel. Similarly, this will be cancelled. This part will be cancelled at here. Fine. You can see, this part will not be cancelled. This part is my 1 over nx plus 1. So you can see if I consider 2 terms, the first and the last term left. If I consider 3 terms, first and the last term will be left. So what is that? It's a 1 over nx plus 1. Fine. Now what is the limit? You can see the limit as n approaches infinity of Sn. What is that? It's a 1 if x is not 0. Fine. But what will happen if x is 0? It's a 1 minus 1, 0. What is the meaning of that? Limit not exist. If limit not exist means it is not continuous. If it is not continuous, it means it is not uniformly convergent. So convergent uniformly cancel out. Convergent pointwise, is it true? Yes. Not uniformly, that's the correct option. Convergent pointwise, correct option, but not for 0, 1, that's the wrong option, because it's there, because it's a uniform convergent of for all x. Why? You can simply see that. What is that? You can although I have not calculated, but it is a very simple. What is that? F. You can see if x is my 0, answer will be 0. If x will be 1, again answer will be 0. If x is 0, answer will be 0. If x is 1, then it will be 1 over n something. So as n approaches infinity is 0. When you take x is lies between 0 and 1 here. So this part will be 1 over n. It again goes to the 0. So does not converges. So the right answer is my B is the correct option. Okay, look at this another one. Find the largest interval B. Again a very simple. The largest interval you can simply say Fine, this is my f. You can find the radius of convergence of this. If I start with the an plus 1 over an, so what is that? This is n plus 1 cos square x over e raised power n cos square x. So this will be my e raised power cos square x. So which is defined all x except pi by 2. Fine, because if you take the limit as n approaches infinity of this, fine, what is the happening at x is equal to pi by 2? This value will be 0, this is infinity, so it's infinity into 0 is not defined. Fine, so what is the answer is, it is defined for all x except pi by 2. So it means this is the right answer. This option is cancelled. This is limited to that, but we can see any, if you look at the graphical representation, this is the graph of 0 to pi by 2, this is the graph of cos x. Fine, and this is value of the pi by 2, but we need a cos square. So what is the graph of the cos square? The first part, and then on this part will move on this upside. This is the value of the pi by 2, just like say cusp or the node. Fine, so what is the meaning of that? The function is continuous on the closed domain of this 0 to pi is the limit, apart from, I can say 0 to pi by 2, open interval pi by 2 and open interval of pi. Fine, so but here you can see say delta, but if I consider delta is say greater than of the pi by 100, then still it's a uniform continuous. So it means it converges uniformly over this answer as the B is the correct answer. This question I already explained you earlier, so the D2 is the simply right answer of this problem. So this is the way you can solve this uniform convergence easily. I hope you can simply like and share my videos. You can find this next lecture on the continuity and differentiability on this again last 16 years papers here. I hope you can like, subscribe and share my videos. Best of luck students. Happy learning all.